My name is Nathan Greiner. I'm with Design Mill. We're a US-based company. Offices in Dubuque, Iowa. That's where I'm from. Charleston, South Carolina, and Washington, D.C. So today I wanted to talk to you a little farther up in the product life cycle related to design and talking about 3D and how to bring that out into the AR, VR ecosystem. Most of us, I think, have 3D models. We've been doing it for a lot of years, product design. So engineering has a whole slew of data that isn't necessarily easily brought out into the real world to this mixed reality. And so that's what I'll be talking about today. So one of the problems we have is, of course, how do we get this data out? And today I want to talk about an example that we're working with the Department of Defense related to a framework. It's a trade space analysis tool way up front, pre-milestone A, if you're familiar with how the systems are designed there. But so I want to show you that example and then bring it back and say this is why we started to go down the AR and VR path. So the FACT is a framework basically for trade space analysis, and this is the big idea in terms of system design. And so what we have is it's based on a SysML, which is a system modeling language. And we have all of these models that converge from the enterprise. So you'll have cost models, performance models, reliability, maintainability, and then further down in the analysis, you're looking at things along the lines of we'll use ANSYS or some kind of electromagnetic design program, and we want all that data to come in. But then we want to visualize it and make decisions very quickly. And then, of course, you see on the other side, we can link out to all of these other systems. So this system is being used exclusively right now in the Marine Corps, but it's also, we're starting to use it in the Navy for ship design. So here's the enterprise that we have. A lot of times we have configuration management issues. You'll see there on the left side, we've got a whole slew of 3D CAD. We have source code as well as all the data. We have external database issues, whether it's Oracle. So very similar things that Bob was talking about. But then we get down and how do we bring that to life in the AR and VR space? And that's where we have to build a visualization engine, runtime, to pull all this data out and bring it to life. So you'll see hardware examples. We have AR glasses, heads-up display. We use RGB depth sensors as well as mobile PC. And then we push it out even to simulation and wargaming type scenarios. So we also have a external API, REST API to link into other systems that are probably in your enterprise that there's no reason to reinvent the wheel. We'll connect to them. So one example, this is bringing, once we get all this data and we can push it out, this FACT program, we bring it in. So we take a design, then we say that's the design we want. Then we want to simulate it, so then it comes through, we call this the simulation horseshoe. And what it is we have a, let's say we're designing a new super tank. And the super tank has to do certain things. It has a new behavior. So this is a path that we use to take the designs that we've iterated, and then we bring it out, apply behaviors to it. This is actually augmented reality sand table. We're showing it in a mission plan, and then we're pushing it out as well into AR, so we're visualizing on top of that AR. So really we can go the gamut on from design to as far right as simulating exactly what the system's doing. So here's an example. This is fact. I mean, what we do is we take all of the design parameters and we say, hey, this is a new vehicle. We want to look at 10 different engine types. And so we have the ability to look at thresholds versus objectives. We give it a stoplight chart. And again, I'm queuing this up because this is, once we get so far down here, it's stuck in this system and we can't get it out for anyone to use or to get feedback from the end user. So this system, we have a complex visualization routine. It's taking data, 3D data, bringing it in with engineering or analysis data, and then making decisions. We utilize a Monte Carlo simulation to be able to do that. So let me bring up a video of that quickly. So basically what we have here is the ability to take in, again, we're taking all the system data and we're putting it together based on options. So we're going to trade off, you know, how much equipment can we put in this, how many radio systems, how can we, is that going to affect the alternator size, is that going to affect the size of the engine, and so what I'm queuing up here is we have all this information in here, and this is really for a product designer or a program manager to use, but we want to take this out into the real world and say, hey, how in the heck is this going to work, for instance, in the field? So we want to push it forward and get a maintenance guy or an operator to really take a look at this. This is showing, you know, real time, looking at the center of gravity of the system. We have a lot of neat tools. This is all web-based, and so now we want to take it and go further down the path. So that's really the start of why we started into the AR space. So the design system feedback loop, this is really the crux of it. So we have these system designers, they're utilizing this program called FACT. We have a proposed design that comes out. Then we start to queue up all of our hardware platforms. So they want to be able to view it in an Oculus Rift. They want to be able to use it in on a tablet, real time, on top of the actual vehicle. So like a dry fit application. Or we can use some type of glasses. And so the objective we see is to minimize the design iterations. Design feedback cycle, we really want to reduce the number of those designs that go out and back. But before we would have to bring everybody in. Now this is, we push it out. We can go ahead and say, hey, everybody jump online. Or hey, walk out to your vehicle real time with your tablet and utilize AR. So that's the exciting part, and we're working on the ability to collaborate in that, and ultimately, hopefully, eliminating a prototype that we can that costs major dollars. So again, I've got the next video here, so apologize now. So this is the system. So we take all of this design data and push it over into a collaborative framework, which allows us to, you know, change the scene, but more importantly, you can see that we can push that instantly into a Oculus Rift experience. And then put this out into the real world. This is, for instance, we're optimizing ship bay to see how many vehicles we can put in there. This is putting an antenna overlaid on top of the real world. And then this is hard system design saying, hey, this is what I want, this is where I want it, and what I want. So this is overlaying real time onto the actual Humvee. And then the network collaboration piece is where we see this is going to be big because we're able to put several people wherever they are throughout the globe, put them together, and they can be on various devices, platforms, and they're all in the same design space, giving feedback in real time. So back to the presentation. And so this is the collaborative framework we have. So up on the left, you see this would be somebody running the design. Again, this has been all exported out of the design software that we did our trade space analysis tools on. And then you can see we can go with an Oculus. This is SLAM tracking. You want to put the Humvee in your office, for instance, or out in your parking lot, or put it in a ship. But then we can also go out to the Humvee and look at, for instance, a wiring harness inside, and then it's really starts to break down the barriers, because what in the past we've had to take this all over and bring develop our own 3D assets for this and then push that out in AR, and it's a lot of time. So this is, hey, we're doing this for design, instantly develop that 3D pipeline that allows us to come out and do these things very quickly, get the feedback that we need, and then continue on down that pipeline. So some of the concerns we have, of course, as we start to ingest large amounts of CAD data, they're not the same. We have SolidWorks, Pro Engineer. What is the base system? And then when you look at a complex manufacturing, you may have varying suppliers that have different CAD systems throughout their entire ecosystem, and that gets a little exciting. So we're building the ability to bring all those CAD into the system. Of course, the hardware devices, we're still watching and waiting for wearables to, I guess, get solid enough that they can be used out on the factory floor. And then, of course, security concerns are one of our big concerns. Access to data. Who gets access to that data? If you look at a wind chill system or Team Center, one of the things is if you're out there and you're linking to that instantly, or for instance, you're linking training information on a critical assembly process, you don't want anybody to doctor that up and potentially sabotage the assembly or maintenance of a critical component. So under current development, this is where we're big into is the automating of the conversion of large CAD data sets, basically to lightweight 3D, which allows us to build that 3D pipeline that I think a lot of us, again, we have all this CAD data, we've got to get that out here into the real world so we can use that in AR, VR, and not have to reinvent the wheel every time somebody wants to do something new with AR and VR. We're looking at the management, thousands of parts. One of the companies we're working with, they have 1 million parts in CAD. So you can imagine the issue in the enterprise when you say, hey, I want to queue up this part. We've got to have that ready to go. And then the matrix approach with threading in all of their enterprise data, with whether it be SAP or Oracle. Authoritative data source connectivity, again, Windchill, Team Center, these type of PLMs, we need to connect to those, and then the automation routines associated with that, and then how can we reuse assets. We're just in the design phase looking at that, but now we want to, once the system is solid, we slap the table and we're moving forward, we can then reuse all these assets in a downstream manner. So, and that's how we're looking at it. We're starting in the design and analysis phase. After that, we're virtual real prototyping, which you've seen, but then taking this and pushing it out into manufacturing, getting that feedback, and then pushing farther down sales, training, troubleshooting, maintenance. So it's exciting. We want to reuse 3D as much as we can because we know that's really where we all start. But then and then go from there. So we're excited because this is just the beginning. We're way up front, and we want to go throughout the entire ecosystem. So, and
Okay.
that's it.